is Cadence. My partner Neha and I will be discussing a multi-scale analysis of structural changes in the heart after left bundle branch block. Heart failure is a life-threatening condition that affects 64 million people around the world. It can be developed from many conditions, but our main focus is on left bundle branch block, a condition where the left bundle branch, a key component of the heart's nerve signaling network, is either partially or entirely blocked. This barrier will delay activation of the left ventricle, resulting in a pathological remodeling. Our comprehension of the connection between alterations at the molecular level and those at the tissue level subsequent to the left bundle branch block remains limited. Thus, our goal for the study is to investigate the alterations in the heart induced by left bundle branch block, both at the tissue and the cellular level. First animal models were inflicted with left bundle branch block, and throughout the course of this 8-week experiment, MRI scans were taken weeks 1, 4, and 8 to monitor the tissue level remodeling of the heart. Once the experiment was completed, histological process and microscopy were conducted on the septal and lateral walls, which Neha will discuss in the preliminary results.
I have preliminary results for inflicted hearts on both the tissue and cellular scale. To start off with, we have MRI scans of the hearts at weeks 1, 4, and 8 of the experiment where left bundle branch block was inflicted in the animal models, as Cadence mentioned previously. In this top image, the 4 walls of the left ventricle have been labeled. There is a clear increase in the volume of the left ventricle, which supports our hypothesis and is supported by the numerical data obtained by MRI analysis software. There is also a thickening and lengthening of the wall tissue. In the graphs below, we will see that there is an overall increase in the arc length measurements of the left ventricle walls from the MRI images. This increase is more prevalent in the lateral wall, where the delay of signaling occurs. The dysynchrony is the cause of this remodeling. The electrical signaling is not as delayed in the septal wall, so the increase in arc length is not as prevalent as seen in the graph in the right. In order to study the cellular level more closely, data was quantified from the microscopy images from the cardiomyocytes using ImageJ and MATLAB. 2 hearts were fully analyzed and compared to a control. On the graphs on the slide, the red bars represent data from the control heart and the green bars represent data from the hearts inflicted with left bundle branch block. We can see a clear difference in the length of the cardiomyocytes in both hearts, as there is a higher percentage of longer cells in the inflicted hearts as represented by the green bars. The comparison of the cross-sectional area or dilation does not seem to have that big of a difference. There might be a slight dilation in the cardiomyocytes, but further analysis will be needed to conduct on more samples to confirm these results. Thank you for listening.